Good evening, dear students. Let us continue our class. Today, what we are going to discuss is coordinates of different centers of a triangle. So first, we'll start with this one. You know, um, we discussed about different centers of a triangle in our one of our previous classes. That is called properties of triangles, and that video lecture is already available both in YouTube and in the online test platform. You can look into it if you want to revise. But today, what we are going to discuss from a coordinate geometry point of view. What does it mean? It means that if you recall about before I proceed, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly?
Yes, sir.
Okay. So, if you recall, the convention is that if this is a triangle, dear students, that ABC is a triangle, then we know there are 6 characteristics. That is, 3, vertices. Sorry, 3 angles and 3, sides. So, what are the 3 angles? 3 angles are capital A, capital B, capital C. And what are the 3 sides? Is that lowercase a, lowercase b, lowercase c. What is lowercase a? That is a side BC, which is opposite to the angle A. What is lowercase b? That is opposite to the angle B, capital B, that is AC. And what is lowercase c? That is opposite to the angle C, okay, capital C, that is AB. So these are the 6 characteristics we are aware of. Now, what we are going to find? We are going to find different centers. If you recall, there are different centers like centroid, then incenter, then excenter, then circumcenter, then orthocenter. We'll discuss all these things in details. So, and we'll find the coordinate of those centers. To find the coordinate of those centers, dear students, we should also be knowing what are the coordinates of the 3 vertices. So let us assume the vertex A is having coordinate x1, y1, x1, y1. Vertex B is x2, y2, and vertex C is x3, y3. These are the 3 vertices. Now, what we are going to do is that first we are going to discuss about the centroid. What is centroid, if you recall? So before that, let me start describing this thing. Just a minute. I hope it is all of you are able to view it, no?
Yes, sir.
Okay, great. So, first point, whatever I wrote is actually what I drawn in the right hand side. That actually it is the English statement, what you see in the left hand side. So, I'm not repeating. So, what is centroid? Centroid of a triangle is the point of intersection of the medians of the triangle, isn't it? That is what you know as centroid. Okay, and let's first understand the centroid by means of a pictorial diagram. So what is the definition? Definition is that it is a point of intersection of medians of the triangle. So how it looks like? It looks like something like this. Let me show you. So if you look into this, triangle, that is ABC, is a triangle, and if you look into the coordinate of the point A, I can write in details coordinate of the point A if it is not very clearly visible, dear students. So I can write the coordinate of the point A is x1, y1, coordinate of the point B is x2 comma y2, and coordinate of the point C is x3 comma y3. Now, as we just understood that the centroid is the point of intersection of the medians of the triangle. So what is median? So median is that from the point A, means from the vertex A, if we draw a straight line which passes through the midpoint of the opposite side of it, that is BC, then we call that line segment is a median. Suppose it, L is the point and L is the midpoint of BC, then we say AL is a median. Similarly, we can get BM is also a median, where M is the midpoint of AC, and we can get CN is also a median, where N is the midpoint of AB. Now, these three medians, AL, BM, and CN, they intersect at a point, and that point is known as the centroid. As you see, it is denoted by G, and it is known as centroid. Now, what we are going to learn is that what is the coordinate of this centroid? Okay, so coordinate of this centroid is obtained something like this. So let's take G alpha beta be the centroid of the triangle ABC, and we can find that it's suppose here is a point G, and we are going to find the coordinate of the centroid. Let's assume that coordinate of the point Z be alpha comma beta. Then we need to express that value of alpha comma beta in terms of x1, x2, x3, y1, y2, y3. And here we get. So it says that let G alpha comma beta be the coordinates of the centroid of the triangle ABC. Now, the coordinate of the point G alpha beta is obtained as alpha equal to x1 plus x2 plus x3 by 3, and beta is equal to y1 plus y2 plus y3 by 3. Okay, so this is what is called as a centroid of a triangle. Okay, this is what is called centroid of a triangle. Next point what we are going to discuss, dear students, is called the incenter. Incenter of a triangle, and what is incenter? If you recall, that it is the point of intersection of the internal bisectors of the triangle. So let us discuss about this thing. Let's first understand what is incenter, and then we will discuss about its the coordinate of the incenter. Okay. So, dear students, if you look into it, let's take this triangle, as you see, the triangle A having coordinate x1, y1, B having coordinate x2, y2, and C is having coordinate x3, y3. And there are these three angles, ABC has their own internal bisectors. Suppose from the vertex A, if we draw an internal bisector of that angle A, then we get that line, suppose AL. Similarly, we get BM, and then we get CN. So what is AL? The line AL is nothing but the internal bisector of the angle A. What is BM? BM is nothing but the internal bisector of the angle B, and CN is nothing but the internal bisector of the angle C. Now all these three internal bisectors, that is AL, BM, and CN, they intersect at a point, and that point we call it as an incenter and denoted by I. Now what we are going to find, dear students, we are going to find what is the coordinate of this incenter. And the coordinate of this incenter is obtained something like this. So if we assume that alpha comma beta be the coordinate of the incenter, okay, and we can find the the value of alpha beta in terms of x1, y1, x2, y2, x3, y3, and ABC is something like this. So let I alpha comma beta be the coordinates of the incenter of the triangle ABC. Now the coordinates of the point I alpha comma beta is denoted as alpha equal to ax1 plus bx2 plus cx3 by a plus b plus c, and beta is equal to ay1 plus by2 plus cy3 by a plus b plus c. Dear students, here ABC are nothing but the the length of the three sides. That is, lowercase a is nothing but BC, lowercase b is nothing but CA, and lowercase c is nothing but AB. And one thing, dear students, is that to remember, you need to remember both alpha and beta. So if you remember alpha, okay, that is which is in terms of x1, x2, x3, you just replace x1, x2, x3 by y1, y2, y3, and you get beta. Clear? So this is the way we can find the coordinates of the incenter. Now, the next point what we are going to discuss is called the excenter of a triangle. And to understand the excenter, so let's first understand that what is excenter. Okay, so let me first draw the diagram and then explain you what is meant by excenter. And I'm going to show you here, and you'll be able to get these notes now first. Let's concentrate on this triangle ABC. Okay, first let us concentrate on this triangle ABC, and for much clarity, I hope all of you are able to view it. The coordinate of the point A is x1 comma y1.
Yes.
Confirm? Great. So if you see, dear students, so this is the triangle ABC. Let me not use red color. Red color is already been used. So it is ABC is the triangle. If you see ABC, this is the triangle. Just focus on this triangle. Now we are going to construct a circle. What it is that the circle touches the side BC. If you see, this is the BC, okay, and the circle what you see beneath it, it is actually touching the side BC, and also it is touching the other two sides AB and AC produced. That means you need to extend it, okay, and then whatever the circle we get, that is called that circle is some property it has, is that it is the bisector of the external angles of B and C. Okay, got it? It is the bisector of the external angles of B and C. So these are the two bisectors. So this is one. So let me use a different color. So this is one bisector. This is one bisector, and those two are the bisectors of the angle B and C, but they are external bisectors. Okay, and then they will intersect at a point. Okay, now that point is known as the excenter, okay, of the ascribed circle. That is why there is a new term I coined here, is called the ascribed circle, opposite to the angle A. Got it? So let me repeat once more. First, you construct a triangle ABC, and ABC is the triangle of our prime concern, because with respect to that triangle only we are finding all the centers. So here we see that ABC, which I draw in the first initially it was in black color. On top of it I give it a blue color. So this is the triangle ABC with the vertex A having coordinate x1 comma y1. Vertex B is having coordinates x2 comma y2, and vertex C is having coordinates x3 comma y3. Now what we are doing is that we are constructing a circle which touches the side BC and also the sides AB and AC, which are produced. Okay, produced means extended. That's why you see it is touching the side AB, but you need to extend that AB. It is touching the side AC, but you need to extend the side AC. Then what the circle we get, it is actually touching BC and AB and AC produced. Now what happened is that there is a this circle, and the center of this circle is nothing but the point of intersection of the external bisectors of the angle B and C. Okay, so then this circle is known as the ascribed circle opposite to the angle A, and the corresponding center is known as the excenter, that is denoted by I1. Why I1? Because similarly for the ascribed circle opposite to the angle B is possible, that excenter should be I2, and ascribed circle opposite to the angle C is also possible, and that excenter we denoted by I3. So I1, I2, I3 we get. And what we are going to discuss, dear students, that what is the coordinates of these points I1, I2, I3. The coordinates of the point I1 is something like this, and I'll tell you a pattern to remember it. Okay. So the coordinates of the center coordinates of I1 is something like this. That minus ax1 plus bx2 plus cx3 divided by minus a plus b plus c, comma minus ay1 plus by2 plus cy3 divided by minus a plus b plus c. This is interesting here. Interesting point is that this is I1 is what? I1 is the excenter of the ascribed circle opposite to the angle A. And as this is the case, what we are doing, opposite to the angle A, so side A should be minus, and denominator also. In the same manner, dear students, we can find the value of I2 and I3 very easily just by remembering one point. Okay, just by remembering I1. And also for I1, you don't need to remember both the x coordinates and y coordinates. You can remember just x coordinate. Y coordinate is similar to this. X coordinate is what? Minus ax1 plus bx2 plus cx3 by a plus minus a plus b plus c. So y coordinate should be similar to that. That is minus ay1 plus by2 plus cy3 by minus a plus b plus c. For that, you don't need to remember, separately. If you can just remember the x coordinate of the point I1, you can find the y coordinate of the point I1, and not only that, you can find the coordinates of the point I2 and I3, where I2 is the excenter of the ascribed circle opposite to the angle B, and I3 is the excenter of the ascribed circle opposite to the angle C. More specifically, I can say that I2 is nothing but the excenter of the circle, which is called the ascribed circle opposite to the angle B, and I3 is the excenter of the ascribed circle opposite to the angle C. So how you can find it out? Just if you notice that I2 should be what? ax1 minus bx2 plus cx3 by a minus b plus c, isn't it? And it is like this. So and let me show it to you in front, and you'll get the pattern. Remembering the pattern is important, because then it will reduce your time to memorizing each and everything. Just by remembering one, you can remember the others. I hope it is clear to you. Let me explain once more. For I1, which is the excenter of the ascribed circle opposite to the angle A, so side A was negative. You see, side A was negative, means there is a minus sign related to the side A. Here also, here also, here also. So the moment we shift it from I1 to I2, means shift our discussion to find the coordinate of the point I2, then what will happen? B should be negative and A and C should be positive. Exactly, that is what has happened here, dear students. B is negative for both x and y coordinate, and A and C is positive. Similarly, when you discuss about I3, then both A and B should be positive and C is negative. Exactly what is happening here, dear students, this thing. Okay, and in that way you can remember the different excenters. That is, there are three excenters opposite to the three ascribed circle opposite to the three vertices. I hope it is clear, dear students. Now the next point what we are going to discuss is called the circumcenter of the triangle. Okay, what is circumcenter? Circumcenter is nothing but the point of intersection of the perpendicular bisectors of the sides of the triangle. Okay, let's understand this thing by means of an illustrative example, so that it will be very well understood. Okay, and after that I will make a quick recap of all these 5 different centers, and you will find it very very clearly understand. You understood everything very clearly. Let me explain you, dear students. So what is circumcenter? Okay, with a representative diagram. So as I said, I repeat the statement once more. Circumcenter is the point of intersection of perpendicular bisectors of the sides of the triangle. So let's assume that this is a, whatever you see in the blue color, that is the triangle with vertex A having coordinate x1, y1, vertex B having coordinate x2, y2, and vertex C is having coordinate x3, y3. Now, dear students, for all these sides AB, BC, and CA, we can draw a perpendicular bisector. What is perpendicular bisector? Perpendicular bisector is nothing but a perpendicular to that particular line. What is perpendicular bisector of AB? Perpendicular bisector of AB is nothing but a line perpendicular to AB, but it is perpendicular in such a way that the point of intersection of that bisector and AB is actually dividing that line segment AB into equal parts. Let me give you an example with an separate way. Let me illustrate, then it will be clearly understandable. Suppose we have this line segment AB, I keep it here. Then what is a perpendicular bisector? Perpendicular bisector is nothing but another line which is a perpendicular to the line AB. Suppose CD is the perpendicular bisector, suppose. Okay, CD is qualifying to be a perpendicular bisector if it satisfies two conditions. First is that CD is perpendicular to AB, that is number one condition. Okay, CD is perpendicular to AB. And the second condition is that the point of intersection of the lines AB and CD, suppose the point of intersection is P, and that point of intersection divides the line segment AB into equal parts. That means what? That means what, dear students? What we get is that AP is equal to PB. So under these two conditions, what we can say? We can say the straight line CD is a perpendicular bisector to the line AB. And obviously the converse is also true. We can say, okay, converse, I'm not going to discuss in the converse because let's not deviate. Okay, then we need to have the CD as a fixed line segment. Let's not get into that discussion. So dear students, so what we see is that circumcenter is generally denoted by S. Then what we get, let me use a different color. So this is S. Now what is SL? SL is nothing but the perpendicular bisector of AB. What is SM? Is nothing but the perpendicular bisector of BC. And what is SN? Is nothing but the perpendicular bisector of CA. Now these three perpendicular bisectors, that is SM, SL, SM, and SN, they intersect at a point, and that point is known as the circumcenter. And dear students, what we are going to do now, we are going to find the coordinates of this circumcenter in terms of x1, x2, y1, y2, x3, y3, and capital A, capital B, capital C, and lowercase a, lowercase b, lowercase c. Okay, because all these things are known to us, and how we are going to find it out? Here it is. So if we consider alpha beta be the coordinates of the circumcenter of the triangle ABC, okay, and we can find the value of this alpha beta in this following manner. Okay, so the x coordinate of the circumcenter, that is alpha, is nothing but x1 sine 2a plus x2 sine 2b plus x3 sine 2c divided by sine 2a plus sine 2b plus sine 2c. And what is beta? Beta is nothing but similar thing. Only one x coordinate you need to remember. Then y coordinate is eventually you can find it out. That is just by replacing x1, x2, x3 by y1, y2, y3. So what is beta we are going to get? Beta is equal to y1 cos sine 2a plus y2 sine 2b plus y3 sine 2c divided by sine 2a plus sine 2b plus sine 2c. This is the coordinate of the circumcenter, dear students. I hope it is you understood it clearly. The next point what I am going to discuss, dear students, is called the orthocenter. Okay, orthocenter of a triangle. Okay, so what is orthocenter? Let's first understand. Orthocenter is nothing but it is the point of intersection of the altitudes of the triangle. Okay, so let's understand this point with a representative example. Okay, and dear students, the orthocenter is generally denoted by H. Okay, so what is orthocenter? Let's understand. Okay, so let us consider the triangle as you see, dear students. So that is the this is the triangle in the blue color. So this is a triangle, so with coordinate vertex A having coordinate x1, y1, vertex B having coordinates x2, y2, and vertex C is having coordinate x3, y3. Now, what is altitude? Altitude is nothing but from the point A you draw a perpendicular to the line, BC. Okay, if you draw a perpendicular from the vertex A to the line BC, suppose we get L be the foot of the perpendicular, then we can say AL is an altitude to the of the triangle ABC from the vertex A to the opposite side BC. Similarly, we can get BM is another altitude which is drawn from the point B, a perpendicular line drawn from the point B to the perpendicular to whom? Perpendicular to the opposite side of that angle B, that is AC. And let's consider the foot of the perpendicular as M. Similarly, we can find the altitude, that is the perpendicular from the point C on the line AB, and let's consider the foot of the perpendicular as N. Then what we see, dear students, AL, BM and CN are the three altitudes of the triangle, and the point of intersection of these three altitudes is nothing but orthocenter. And what is actually written there? Orthocenter is the point of intersection of altitudes of the triangle. Now, dear students, what is our task? Our task is to find the coordinates. Our task is to find the coordinates of the circumcenter of the triangle ABC. So how we can find the coordinates of the circumcenter of the triangle ABC? And here is the way we can find it out, dear students. Okay, if we consider that H, the circumcenter is denoted by H, capital H, and it's having the coordinate, orthocenter H having the coordinate alpha, beta, then we can find alpha as x1 tan A plus x2 tan B plus x3 tan C divided by tan A plus tan B plus tan C. In the similar manner, we can find beta. Beta is nothing but replacing x1 by y1, x2 by y2, and x3 by y3. As simple as I said in the beginning, dear students, and also few times in between, is that if you just remember the only x coordinate, we can find the y coordinate. Okay, so these are the different centers we have discussed, dear students. So there are 5 centers we have discussed. What are the 5 centers? Let's make a summary of it before we discuss for their relationship among those centers. Okay. So let's have a quick recap. The first, center what we discussed is called the, sorry, just a minute. The first center what we discussed is called the centroid. Centroid is nothing but, as we discussed, dear students, that centroid is nothing but the intersection of the medians of the triangle. Okay, and if x1, x2, x3, and sorry, x1, y1, x2, y2, and x3, y3 are the coordinates of the 3 vertices of the triangle, then we can find the coordinates of the centroid of the triangle as x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Now, the next point what we discussed is that incenter of a triangle. What is incenter, dear students? Incenter is the point of intersection of the internal angle bisectors of the triangle. If you see in the diagram, dear students, that ABC, as you see, their coordinates are given x1, y1, x2, y2, x3, y3, and if we draw the 3 perpendicular not perpendicular, slip of my tongue, dear students, it is the internal angle bisectors, and then we find their point of intersection is I, and that is called the incenter. Next, we discussed about the excenter. What is excenter? Excenter is, there are 3 circles possible. You have 3 ascribed circle. So if we discuss just one, is the, suppose we consider a circle we construct a circle which touches the side BC and also the side AB and AC, but they has to be produced. Okay, means extended so that it can touch. You can construct the circle which is touching all the three sides BC and AB and AC extended. Then the center of that circle is called the excenter. And that center of the circle has a property is that it is nothing but the point of intersection of the two external bisectors of the triangle in ABC. That is the external bisector of the point B and external bisector of the point C. They intersect at a point, and that point is known as the excenter of the circle we are discussing now. So now how to find it out? So there are three excenters as we discussed. So first coordinate we can find is that minus ax1 plus by2 plus minus ax1 plus bx2 plus cx3 divided by a plus b plus c. That is the x coordinate. And y coordinate eventually we can find it out. That is minus ay1 plus by2 plus cy3 divided by a plus b plus c. That is what is called excenter. Then the next one what we discussed, dear students. So after centroid, then incenter, then excenter. After that, what we discuss about the circumcenter. Circumcenter is the point of intersection of the perpendicular bisectors of the triangle. Okay, so as you see that ABC is a triangle, so for each of these three sides there is a perpendicular bisector, and these three perpendicular bisectors, they actually intersect at a point, and that point is known as the circumcenter of the corresponding triangle. Okay, corresponding triangle means I wanted to mean is that it is a coordinate of the circumcenter. Okay, and that circumcenter means it is a center of a circle, and that circle is actually passing through all the 3 points ABC. Okay, so now how we can find the coordinate of that that circumcenter, and it is actually done in the following manner. Just I'm going to show you. Okay, so how we can find the just a minute. Sorry. Yeah. Sorry. So we found the coordinate of the circumcenter as alpha equal to x1 sine 2a plus x2 sine 2b plus x3 sine 2c divided by sine 2a plus sine 2b plus sine 2c, and beta is equal to y1 sine 2a plus y2 sine 2b plus y3 sine 2c by sine 2a plus sine 2b plus sine 2c. As I said earlier, dear students, that you just sorry, we were discussing about the orthocenter. Sorry, let me get back to orthocenter. Yeah, as you see, dear students, that orthocenter, as denoted by H, and we find the coordinate of the orthocenter as x1 tan A plus x2 tan B plus x3 tan C by tan A plus tan B plus tan C. And what is orthocenter? Orthocenter is nothing but the point of intersection of the altitudes of the triangle. And before orthocenter, what I wanted to discuss with you is that it is called the circumcenter, which is nothing but the point of intersection of the perpendicular bisectors of the sides of the triangle. So, dear students, we found there are 5 different centers. The first one is called the centroid, which is nothing but the point of intersection of the medians. Second one is called the incenter, which is nothing but the point of intersection of the 3 internal bisectors of the vertices. Okay. Next one we discussed about the excenter. Excenter is actually there are 3 ascribed circles. Okay, one ascribed circle, what I can say is that suppose we are going to find that we are going to construct an ascribed circle opposite to the vertex A, then that circle should touch the side BC and also should touch the sides AB and AC produced. Okay, so now that is what is called the excenter of the ascribed circle opposite to the angle A. Similarly, we can find I2 and I3, which are the ascribed circle opposite to the angle B and angle C respectively. Then finally, we discussed about the orthocenter, and what is that? Orthocenter is the point of intersection of the altitudes of the triangle. Okay, so altitude, that from the point A, that is the vertex, if you draw a perpendicular. Okay, now from all the three vertices, you can construct three perpendicular lines. Okay, and the point of intersection of this perpendicular line is known as the orthocenter. Okay, dear students, I hope you got it clear about the orthocenter. Now, what we are going to discuss, there are some important points I would like to tell you about these five centers. The centroid, orthocenter, and circumcenter all fall in a straight line. So the first point, what is that? The centroid, the orthocenter, and the circumcenters all fall in a straight line. So let me show you the points, dear students. Okay, the first point what I'm saying is that, dear students, is that the centroid G, the orthocenter H, and the circumcenter S all fall in a straight line. And the second point is that the centroid G is always between the orthocenter and circumcenter. Okay. Third point what I'm going to say, dear students, is that there are total 6 points. Third point is that the distance between the centroid and orthocenter is always twice the distance between the centroid and the circumcenter. Okay, so you can you can construct all this and make that experiment at your end as well. But from an entrance point of view, you need to remember this thing, because this memorization will help you to solve problem in relatively lesser time. And the third point is that as I was just telling, the distance between the centroid and the orthocenter is always twice the distance between the centroid and the circumcenter. Point number 4 is that in obtuse triangle, the circumcenter is always outside the triangle, opposite to the largest angle. The orthocenter is always outside the triangle, opposite the longest leg on the same side of the largest angle. You can all experiment this. Point number 5 is that in any equilateral triangle, the centroid, the incenter, the circumcenter, and orthocenter all coincide. And point number 6, dear students, in any triangle, centroid, circumcenter, and orthocenter are collinear, and centroid divides the line segment HS, that is the line segment of orthocenter and the circumcenter, in the ratio 2:1 internally. So these are the points I just wanted to discuss with you. And you may think, or whether this point come to your mind or not, that's how we can derive. You said all these coordinate points, but is the derivation important? Dear students, derivation is not that very important as long as the entrance exam is concerned. But in my study material, you will find all these derivations are there in details. That is how we can find the coordinate of the centroid as x1 plus x2 plus x3 by 3. How we can find the coordinate of let me come back to this thing. Yeah, how we can find the coordinate of the centroid as x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3, as you see it here. Okay, so there is the derivation, and that derivation you can look into it in my study material, okay, which is available in the online platform. And similarly, you can find the coordinates of the derivation of the coordinates of the incenter, as you see it here, okay, in the derivation. But very frankly speaking, as long as your entrance is concerned, you just need to remember these centers, and you need to apply this in while solving the questions. Okay, in the similar manner, excenter coordinates you see, okay, which is given here, excenters I1, I2, and I3, and then Next one, we discussed about the circumcenter, and circumcenter, as you see, this is the formula, okay, about the circumcenter. And finally, we discussed about the orthocenter and orthocenter formula, as you see, it is in front of you. And last but not least, dear students, the properties what I discussed, these points, remembering these points are important. Sometime in JEE Advanced especially, you will get questions. So, where you need to apply these points, to proceed further. Okay, so that is why it is important that you remember these points as well. With this, dear students, I would like to conclude the class, because the next point what I am going to discuss is called the triangles. Okay, the area of a triangle. Okay, and it will take a relatively longer time to complete the area of a triangle, then area of a polygon, then how we can find the condition of the collinearity of the 3 points, and all these things and other relevant stuff we will be discussing in the next class. Okay, dear students, so with this I would like to conclude the class for today here. If you have any specific question, please feel free to me. Okay, if you do not have any question, it is perfectly fine. Or if you have any question, you let me know. All right then, thank you very much.
Thank you.